Hello, my name is Gabriela Obando, and today I will be talking about the efficacy of bioacoustic monitoring of bats across North America. Interest in bat population status has developed rapidly in the face of climate change. Techniques such as mist netting are being replaced with research focused on gathering bioacoustic echolocating data in an effort to develop standardized protocol for better identifying species and build a library of data for future use. However, such data is challenging because there is significant species variation in calls given off by bats. These elements combined have posed a significant issue in understanding bat population density and abundance via acoustic data. Today, there are varying tools and techniques used to conduct acoustic monitoring, with each having their own costs and benefits. One such tool is heterodyne detectors. Heterodyne detectors are tuned to a narrow range of frequencies and convert sound of those frequencies to an audible sound in real time. This provides a quick method to listen for bat presence. They are a low-cost tool, and like experienced birders, a well-trained specialist can identify bat calls to species simply by listening to the output of the detector. However, the detectors provide little information on call structure and require high amounts of storage. Additionally, it requires the researcher to have significant knowledge on local populations. Another type of surveying tool are broadband detectors. Most survey efforts typically require broadband detectors, which record a range of frequencies simultaneously to identify species, especially in communities where calls are varying. This is unique to heterodyne detectors as broadband detectors mainly use zero crossing or Fourier analysis to process digital calls. Another issue posed by gathering echolocating data is the identification process. Research focused on bat population monitoring conduct the identification process in two ways. One such process utilizes manual identification. This technique identifies call sequences through visual and auditory comparison with a known call library. This is also called qualitative call ID identification. It utilizes heterodyne detectors, can be combined with automated detection software. It additionally offers a quantitative approach by varying the amplitude threshold to determine the effects on spectrogram visualization. It allows researchers to set up their own library focused on local populations, and when combined with field visualization, is very effective in identifying species. However, it requires the observer have significant knowledge of the calls that the target bat species produces. It requires that calls be visible in real time on a detector or be recorded. Overall, the main concern in using manual identification techniques is that there is substantial variation in the qualitative results within and among researchers. There is additionally little standardization in the process used for manual identification by different researchers. Another technique that is used for species identification is automated identification. Automated identification software is increasingly being used to identify call sequences of specific species from large amounts of data recorded by modern detectors. Thus, progressively gathers data on species identification and is constantly adjusting for accuracy. Echolocation calls using software may be accomplished using varying methods, algorithms, and softwares. It is easily repeatable and often avoids observer bias, utilizes machine learning, and there has even been a function developed by a researcher to compare software accuracy. One of the limits of using automated identification is that software programs available require different types of recorded data, from zero crossing to the Fourier analysis. Accuracy of identification algorithms is also dependent on the training data that is set to generate the algorithm. It's also challenging to categorize files that are known to be a bat species, but not identifiable any further because unidentifiable calls from different species may have highly dissimilar characteristics. Overall, researchers are continuing to assess the costs and benefits of varied collection and helping to fill the gap of effective monitoring plans. A common limitation in acoustic studies is the absence of well-developed call libraries that allow researchers to assign recordings to species, genus, sonic, or phonotype group. One way to begin this process is by focusing on populations that are common and establishing a reliable call library that many researchers reach a consensus on. Additionally, organized groups of well-trained researchers, such as the North American Bat Monitoring Program, should continue their efforts of working in conjunction with other data, including those from acoustic transects, as well as visual counts for population monitoring. As technology develops, these issues will occur far less, but it requires those with a diverse set of skills to work together on this single issue. Thank you so much for watching my presentation, and thank you to Dr. Bone and Dr. Romagosa for your time, mentorship, and energy given to this course over the semester. Have a great day.